Well, hello everybody, and welcome to this discussion with Yuvoh on the RICS Tech Partner Program. I'm Andrew Knight. I head up the data and tech analytics side at RICS as part of the standards, regulatory and thought leadership part of RICS. And this afternoon, I'm talking to Manish Shah of Yuvoh, one of our tech partners. So welcome, Manish.
Hey Andrew, thanks for having me. I hope we have a fruitful discussion, and hopefully some of the topics we speak about today are helpful for some of your members.
Indeed, great. Well, what would be great first would be a bit of an introduction from yourselves, both in terms of Yuvoh itself, why you started it, and also your own backstory, what you're bringing to this this data and tech world within real estate.
Sure. Yeah. Look, why don't I give a bit of a background on me first? So, yeah. Look, I'm not a real estate expert. Just to be very clear, my career actually started in a very different manner. I've been an investment banker for pretty much most of my career post graduating. So I graduated in the early 2000s. Most of my work, and certainly the latter part of my work, was really focused on mortgage M&A. As part of a disposal of one of the sort of large bad banks that were created from the previous crisis in 08 and 09. So as part of that there, I was doing a lot of mortgage M&A, which required, of course, some of the mortgage collateral to be sold. And of course, as you can imagine, any buyer who's looking at potentially purchasing that collateral of mortgage pools would want to know what the underlying real estate value is and how they would sort of go about optimizing that there. Now, as part of that process there, it was a bit of a backwards process, to be very open and honest. You would get, let's say, 10,000 line items in country A, and you would want to know what the physical or what the valuations were for those properties there. And typically a physical valuation or a drive-by valuation would be conducted, but on a very small sample, maybe 200, 300, 400 properties. So you'd have possibly one of your panel members from RICS coming through and looking at whatever country it is, and typically looking at the right tail, and that be that. The rest of the portfolio, so the very, very, very vast majority of the difference, unfortunately, the process was an extrapolation approach, and it wasn't very sophisticated. Some of these properties were originated, or some of the mortgages that back those properties there were originated 20, 30 years ago, and an extrapolation approach seemed very archaic given what we're doing. And of course, as part of that process there, you can imagine what that meant for buyers and sellers, in terms of the sellers trying to say, well, look, I've got some really good information, when actually, you haven't, and the buyer saying, well, I'm not so sure. And of course, when transactions are conducted, the bid ask starts to widen, which is exactly where you don't want to be. So look, that's kind of why I'm here today. I felt as if there was a much better way of doing it, which is why I left the firm and started this business probably about 4+ years ago now. And that's why I'm here, sort of speaking to you today.
Well, that's great, Manish, and I guess it's always interesting, I think, for people to come into the sector with, if I can use the expression, a fresh set of eyes, because clearly you're looking at the definition of value from that capital market perspective, that, bad bank, as you say, those kind of non-performing loans type view, and clearly there was a real imperative to get some valuations on these non-performing loans to understand how these books could be traded at a fair value, quite literally in financial terms. And I guess it's interesting for somebody to come to an asset type like real estate, with all its idiosyncrasies, if I can put it like that, with the kind of disciplines of the capital markets and those kind of views. And in fact, that's very much the theme we wanted to explore today, around what are called automated valuation models, because clearly what you've talked about in that kind of financial sector perspective is that kind of mass appraisal, that looking at in that case, a loan book with a large number of properties, where you need some kind of methodology which is clearly going to establish fair value, but has to be done at scale, but still within reasonable confidence levels for both sides, both seller and potential acquirer of the book, as it were. So I guess a challenging question for you initially is how would you describe an AVM, and what's the concept of an automated valuation model, given the approaches you've taken?
Yeah, no. So look, I think the first thing, and hopefully it's relatively obvious, but you do need a large amount of data. and you need to have a large amount, of course, of relevant data. Now, I'm sure later on in the presentation we'll talk about accuracy and the types of data that you can get, but ultimately an automated valuation model is consuming data in a very efficient manner, using some of the techniques that you can do with big data and cloud technology today, and then providing you with an output of what the value of a property might be. Now, as I mentioned, in terms of AVMs, you can use them in different forms, and again, I'm sure we'll talk about it a bit further when you look at sort of different countries. But you could be doing it for new lending business, new acquisition business, depending on the quality or the data availability within the country, or where we've tended to focus, although we are starting to sort of do other things. Where we started certainly was we were doing it on bulk valuations on 20,000, 30, 40,000 line items. So it's an automated way of essentially providing you with quick, efficient, and timely and cost-efficient answers, really.
Thanks, Manish. And if somebody was to kind of almost challenge you, albeit in a friendly way, about the kind of the pros and cons about when to use them, when not to use them, and where the limits are, what would be your kind of your short summary of the advantages, and also perhaps situations where they need to be used with even more care, or where there are limitations around it?
Yeah, no. So look, I think there's definitely pros and cons to everything, and when something is new and fresh, I guess the thinking is there's probably going to be more cons than there are pros. I'm not quite sure that's the case anymore. I think the use of AVMs has started to be adopted across Europe. I think some of the northern European territories were the sort of early adopters, let's say, and actually we're doing a fair amount of work now in southern Europe as well. So I think the first thing is, of course, if you're talking about, and it depends on the type of task that you've got given to you as an RICS member. So if a customer comes to you and says, look, I want 3 properties valued that are relatively large and big and commercial in nature, I think there's nothing wrong with just doing what has already been done in the past. That's not a problem. However, if a customer comes to you and says, well, look, I need to value 20,000 residential asset classes that back a mortgage book or whatever it might be, you can imagine the time and the cost required to sort of do something like this. And by the time you've done the 20,000th one, the first one you did is probably a year or two old, I suspect, given the resource constraints that you'd probably no doubt be facing in a manner like this. So I think the first thing is, certainly from a pro perspective, it's a time and cost efficient way of you actually going about looking at the book. The other thing as well is, like, I'm sure there are thoughts about, and we'll come to the cons in terms of accuracies and some of these things here. But one of the things that you clearly can do, and what we have done, is we've done a lot of back testing with RICS members. So it's not a case of just throw in the model and just say, oh well, there's some output there, and let's just trust it. There is actually quite a bit of rigor that goes through, and making sure that actually you do go and back test it. So then it starts to become a bit more trusted in what's going on, and we'll talk about explainability and a few other sort of factors a bit later on. I think the other thing as well is that the adoption has been, I think it's fair to say in Europe it's been slower than in the US. In the US you do have AVMs, and they've been around for a significant period of time. Now, the difference between the US versus Europe is, of course, data availability. Now, if you've got rich amount of data, then actually to create automated valuation models is actually a bit easier. Having said that, of course, in Europe, and there's a patchwork of countries across Europe who've got different types of availability. The adoption has been a bit slower. Having said that, there are regulatory wins that sort of change the adoption cycle. So, by way of example, the European Banking Authority in 2020, they basically gave guidelines on loan origination and monitoring. And basically, in sort of section 210, they were talking about the adoption of AVMs and the use cases that can be applied within sort of new origination, legacy origination, and this type of stuff. So the adoption cycle is certainly coming, and I think that's probably one of when I first started, I would say actually that's probably a con, because the adoption was really slow. But I can see the headwinds are changing, and it's becoming a bit easier. So I think the problem with some of these sort of AVM approaches, of course, the adoption is obviously it's not there yet. It's gonna start to get there, and I think it will become more prevalent as time sort of goes on. However, some of these models are quite complicated in nature. So you have more simplistic, I guess, comparable models that don't require too much in terms of sort of mathematical thinking and know-how, etc. They're fairly well explained, etc. And then you get to very technical models like machine learning and AI-driven approaches. Now, what does a RICS firm do? Do they sort of go and hire? And I suspect most of your members are very much real estate advisory experts. Is kind of what I suspect they are. They're probably not, from Google or Microsoft or from a technical background. Is my strongest suspicion with the interactions I've had with some of your members. So the problem is that you've got firms who are very good experts at a certain domain, but then they're trying to build something that is not their expertise. And we've seen this, and we've had conversations with some of your members where they've spent a rather large amount of money on an IT project, which has gone really nowhere. And you've got people who may be real estate experts who are making decisions on hiring people who are technically really good at coding and some of the languages that you might be thinking. And how do you go and build that gap of saying, well, look, we're hiring the right people, we know what they want to do, and how do you do that? And then there's the explainability, which we'll come upon a bit later on as well. So some of these models are quite complicated. So you can have a very proficient modeler, but you also need to have a deep mathematical bent as well. So those are some of the challenges that we sort of see in this industry. Adoption is occurring, but then do you go and build the solution in house, and how challenging can that be within the sort of framework of a real estate expert?
Thanks, Manish. I mean, I suppose as ever, the starting position, and you mentioned some of the challenges about different jurisdictions, is obviously the data. Any kind of model, whether it's a relatively simple statistical regression or a more complex machine learning piece, needs a data. What kind of data sets? It may be an obvious question, but what sort of data sets are key? Because obviously different jurisdictions will have different availability of that. But from a data perspective, what are your bare minimums, as it were, and what would be your ideals for data set availability to drive these kind of approaches?
Yeah, no. So look, hopefully you can see the second slide here. I mean, look, this is a very generic view, so don't assume you can apply to France or Germany, or please don't take that assumption. But yeah, I mean, look, we consume a huge amount of data sets. So again, every jurisdiction is going to have its own little quirks, as I'm sure you know. So sold house prices. So in the UK, you've obviously got things like land registry. Great, really accurate compared to some of the jurisdictions that we've worked in Europe, but clearly that's a very useful input in terms of how you go about defining what some of the values are. What we've also noticed is that there's a lot of geospatial features, and I'll talk a tiny bit about comparable model versus sort of a machine learning model. A machine learning model will be taking a lot more sort of geospatial and augmented data as well. So how far away a property might be from a school or a train station or a beach resort or something else that is driving value. In a more simplistic sort of comparable model, you might have 5 properties, all 2 bedrooms, and ranging from 300 to 400,000 pounds or euros. Your one must be 350. Now, what you don't know is actually your one happens to be the closest to the tube station, or the furthest, or in a really good catchment area, or something else. So there are lots of drivers of value, and if you're not consuming a lot of geospatial factors, it becomes quite tricky. Of course, you've got your usual types of characteristics like your long-term rental, your 4 listing portals, etc. There's some more statistical data. And a whole bunch more, and I'll talk about Airbnb and sort of some of the unusual data sets as well in some of the other slides, and why we think actually they're quite important. So again, hopefully you can sort of see the next slide here. So there was a study done by McKinsey a couple of years ago now, and you've got your traditional metrics. What are the nearest properties selling for, the year of build, and the usual stuff that you would normally have a look at. However, what what McKinsey had stated, and we'd already started down this journey by a year or two by this point already, is they said, look, you really need to look at the non-traditional aspects of property valuation. So they looked at sort of proximity to 4-star hotels, number of coffee shops within an area. This is obviously quite important. And if you're a physical RICS valuer, you know this, you know your area, you know your patch. But if you're doing it en masse, of course, it becomes quite tricky, as I'm sure you appreciate. So we basically went and ran, you know, a lot of different types of models, and to try and distill what the variable input drivers are to house price. And they vary, of course, across region, across countries, etc., and all the rest of it. So again, don't assume what I've got here is appropriate for your specific jurisdiction. But in this example here, we're looking at Athens, and I've sort of circled here average Airbnb price and sort of nearest shopping mall or shopping destination. So some of the things that we're able to do with big data and technologies, by way of example, Yuvoh consumes, I think, we've got almost 4 years worth of Airbnb occupancy seasonality void period and data like this. So in Athens, you can see that the 6th highest driver to house price, and okay, it's a very touristy area, as I'm sure you've already guessed, is the Airbnb. This is not something that you traditionally pick up. The other thing, of course, is nearest sort of shopping destination. Now, how do you define that? Because normally you just say, well, where's the biggest shopping mall? And it's not as easy as that there, because you know, in this example here in London, and I'm sure this occurs all over Europe, this is Camden Market. Now, for people in the UK, they're very well aware, Camden Market, Oxford Street, they don't actually have shopping malls per se, but these are dense, retail-dense destinations. And again, using some sort of geo-clustering technology that we've built in-house, you're able to sort of distill, actually, this is a rental, you know, a good retail destination, which is, of course, driving house prices. Now, I'll go through to, sorry, a couple of other slides. I could have ordered these a bit better,
no,
but hopefully, no, not the right one. Slide 9, so hopefully you can see this.
Yeah.
You know, the question was, what kind of data do you need? I think it depends on the type of modeling approach you are trying to take. So, by way of example, I talked about a comparable model. You know, generally you're talking, you know, tabular form, numeric data with some alpha data with drop downs of detached house or semi-detached or whatever it might be. So it's consuming a different type of data to what you might be doing from a machine learning approach. So of course, a machine learning approach will of course be taking this textual form as well as numeric form style data. But the things that you can do with big data and AI nowadays is you're able to use and sort of compute different things in different ways and look at things that you may not traditionally have been looking at. So augmenting features. So I mentioned about the sort of geospatial factors. So if you get a data tape and you've only been given, let's say, 10 variables from a bank, but you've not been told how far away the nearest train station is, or the nearest school, or this or that, or other parameters, you're able to add extra variables into your data set and then use that as part of your as part of your driver. Non-traditional data, and this can come in many different forms, but I think I'll just use a very simplistic example. So we're able to consume things like imagery data. So what we've done in a project in Spain is we've looked at sort of satellite imagery. And what we're looking to do is we're looking to distill, certainly on the right tail, the more expensive properties, the things like the swimming pools and where they are and detect where they are. And of course, if you've got a swimming pool, you can probably bet that it's actually worth more than a property that isn't without a swimming pool. So you're able to distill this because the data that comes in, you're not really in control of that. That's the customer. That may be a lender. That may be somebody else. And, you know, as much as I would like to think the customers have got fantastic data, more times than not, you are going to be left lacking sometimes. And being able to augment these features and consume alternative data in different forms means that you're actually able to, you know, provide more accuracy given the data information you get. And again, I think also I'll touch very quickly on the types of asset classes. And I think again this should be hopefully fairly obvious. But of course, the more data that you have, the more granular it is, the lower the error rate and the higher the accuracy. So residential and land tend to be, very AVMable, I will say. And then depending on the country, you can start to look at some granular commercial. We have piloted an AVM in commercial real estate in Korea recently. But there are some problems, and I think we'll sort of talk about that in terms of what the future holds as well. So, yeah, I hope that answers your question. Sorry if it's slightly long-winded.
No, that's fine. No, I mean, I'm interested to sort of dig a bit deeper about that whole area around, how, and for many of our viewers, that they'll probably be slightly new to this concept of machine learning and training data, and around how they will be able to consume what they might be familiar with in terms of a confidence level, because you've obviously talked about that kind of accuracy piece, and also that word that we've talked about in terms of explainability. So it's, if you were sitting in the kind of shoes of the client who's requested all these valuations, it'd be interesting to sort of understand how you'd be talking about how the machine learning is being trained, and how you can bring those confidence levels and explainability, because I think that obviously builds confidence when people understand what the value drivers are and how a model has established, as you said, whether it's those geospatial coordinates, what actually is driving value, because ultimately this is a model that is reflecting the way human beings place value on property, the somewhat sort of almost irrational sort of set of decisions that people make when they look at housing, particularly residential. So
yeah, no, look, it's a very good question, and I think it's something that I won't say is easily explained, but I think certainly in this sort of short segment, I can try and do certainly a bit of a helicopter view of how to look at this. So yeah, look, in terms of sort of training data, so let's just think about the UK for a second, because I think that will probably just make it a bit easier as a concept to grasp. So in terms of training data, think of the amount of information that is out there, be that through land registry, Rightmove, Zoop listings, and other sort of, and I sort of had that light bulb of information that you sort of consume. So essentially what you're looking to do is you're trying to consume in a very sort of relatively simplistic way a sort of tabular and structured data. So number of bedrooms, number of bathrooms, house price for sale, this, that, the other, and the usual types of data that you traditionally think about. Now, the other thing as well is you want to have a large volume of that data as well. And again, thinking about the UK, Rightmove, Zoopla, you've probably got about 1 million listings or so. You've got about 30 million properties across the UK. So that's a very large amount of data for you to sort of start to think about your training your models on. Now, before you start training your models, you need to do a few other things. So as I mentioned, feature engineering, you've only got, let's say, 10 variable inputs to deal with right now. Now, using things like Google Maps, etc., you can find out how far away a property is from such and such POI or anything else that might be driving house prices. The second thing is we need to think about sort of cleaning. We need to think about cleaning the data sets as well. So if you're getting slightly corrupted data, so you might have floor as a parameter input, and it might be ONE, it might be numeric 1, it might be first, all meaning exactly the same thing. That's going to throw off the model. So you need to think about cleaning your data sets as well. And you also need to think about something known as feature transformation and normalizations in particular. So you might have a lot of skews. So you might have a right tail skew, a left tail skew in terms of your data sets, etc., depending on the parameters that you're looking at and the variables that you're looking at. And if you can try to normalize that through square roots and a few other sort of functions, then it becomes easier. Essentially, what you're trying to do is you're trying to give the machine as normal a data set as possible. And however you try to augment it, that will help when you start to build the models. And of course, you'll undo all of those things later on. So, those are the types of things that you need when you're talking about your training data sets. And then what you essentially do is you have an 80-20 rule. So you've got 1 million listings, you've got 800,000 that you're training on, and the 200,000 you're testing on, say, reveal the price, reveal the price, reveal the price. And you sort of iterate through that process there. And essentially what you're trying to do is, of course, squeeze down the error rate, saying, well, look, chuck in another parameter, chuck in another variable, try a different methodology, try a different sort of mathematical technique to go about that there. I think the other thing as well is you need to be very, very conscious about the data that you're consuming and how good and accurate that data is as well. Because if you throw in garbage, you're going to get garbage out, of course, at the end of it. So again, let's use the UK. We've worked across a few jurisdictions, so we look at the sort of UK and Greece as sort of two kind of polar opposites, I guess. So in the UK, as you know, we've got a vast amount of land registry data, pretty accurate. Yeah, on the odd occasion, something might have happened, but, pretty reasonable, pretty accurate. And you can see what house prices are trading for as a broad rule of thumb. You can merge that with EPC and put square meterage and other things like this, and you get a good sense of what's happening. In other jurisdictions, let's say again like Greece, what we have from their equivalent of the land registry is a liquidity metric is kind of all we can use, because if you believe the statistics that are being produced by the government, then the average house price is about 30,000 euros across the country, which is just not the case there. Now, because of taxation and a few other things like this, there tends to be a slight underdeclaration, which means that you can't really use that for accuracy of house prices. So, when training the model, you need to be basically an RICS expert, really, to know what you're dealing with, to know that it's accurate or inaccurate, and the reasons why. And then you can start to train those models. So you can build out models. You just need to be very conscious of what data is coming in, how you're consuming it, and most importantly, how accurate it is. So hopefully that sort of answers the sort of training aspect of things.
It does, and I guess it highlights the fact that these tools aren't magic. They need, and perhaps supervision is the wrong word, because that implies a fairly low-level piece of interaction, but it needs that human experience and judgment to understand the raw material, as you say, before you let these algorithms run riot, as it were, when they haven't been given the right data. And as you say, that very old-fashioned garbage in, garbage out still holds true, whether it's a complex algorithm or a very simple system. I guess that other question I had around explainability always fascinates me, because I think, as you know, valuers have to provide effectively an explanation of how they've come to a particular value. And I guess I'm always interested to understand how an algorithmic approach, whether it's machine learning, whatever kind of terminology one might want to use, how you can effectively say, okay, well, you've given me either at a book level or at an individual asset level, you've given me a value here. Can you tell me what the value drivers were? What has driven this particular property to be worth X 100,000 euros? Is it that geospatial information in terms of school catchment, other amenities, the changing tastes in terms of outside space, more bedrooms for home offices? It is that classic, well, why is that one worth more than another when it's only 2 streets away and they're both 4-bedroom houses? That for me is a very intriguing piece, in fact, about the whole kind of artificial intelligence discussion, is that explainability. How do you actually know why the machine came to its conclusion?
Yeah, no, I think you're really touching upon a topic that we see with our customer interactions. It's, can I trust this? Am I confident in the output? Why am I confident in the output, etc. So I'll talk about confidence intervals, back testing, and of course explainability, which is what are the drivers of the price of these properties. So one of the things that we do with some of our customers, of course, they're RICS members, and we will say, well, look, we want to backtest and make sure our modeling inputs are done appropriately. So again, you can hopefully see this on sort of slide 8. Yeah. In green, what you've got there is you've got a drive-by valuation. So a physical drive-by valuation has been conducted. We basically went and did a backtesting using a comparable model, and as well as a machine learning model here as well. And essentially what you're looking to do is you're trying to draw a tracing paper and just say, look, which one fits to the green there. And it's not a surprise. We basically said, look, on the right tail, things start to fall away. There's not a lot of data coming out there, so we basically shut off the model at 1.5 million. So that kind of approach is what we do, and sort of give confidence. Now, of course, you've got two extremes as well. You've got that 10 million pound mansion There's not a lot of data points there. So, as I mentioned, we're going to say, well, look, better off actually getting a physical valuation in that instance there. And of course, there's things that the model at this point in time we can't do. So I talked about something known as computer vision, which was a satellite imagery of the property. Now in the UK, there's obviously quite a few properties that are in dilapidation. You might have the quintessential sort of granny fats when they pass away and then they go into probate, etc. They're in disrepair. They're not going to be of a market standard in that geospatial area. So how do you go and do that there? So you're looking at your traditional your 5 and 95 type confidence intervals, but there clearly are going to be some extremities which make it a bit more tricky to say, well, look, this is going to be 100% accurate. But on a portfolio basis, of course, these types of things completely net off. But if you're talking about one property for 100 million, you go with the traditional type of approach. I think you talked about the sort of explainability, and I'll probably just go back to this previous slide here on slide 4. So you can go and do many things with sort of machine learning. Now there's a concept known as neural networks, which is essentially a black box type technology. To provide explainability, it is significantly harder than would otherwise be the case. Now machine learning gets thrown around quite a lot, but essentially it's a econometric model is essentially what it is. Lots of variable inputs, and then figuring out what those variable inputs are, and then saying, well, look, this one here is really driving something, and this one here has only got a marginal type benefit. So we use different types of machine learning regressor models to go and figure out what the drivers of house prices or rental prices or whatever it is might be. So again, if you can see in the sort of top right here, it's not a surprise. Location is the biggest driver to house prices. Now, you try, if you go to the 6th one, you try and tease that out, and we're trying to break it out into more and more fragments. So the nearest Airbnbs around you is a component of basically location. So if we didn't have Airbnbs, you can probably imagine we can just take this and stick it on there, and it will carry on being something like that. So you're trying to distill and say, well, what in that location is actually occurring that's telling you what's happening there. And then, of course, you've got the usual things, build year, square footage, floors, etc. But what you can probably see here is the geospatial aspects, how far the augmented features come to the fore. Distance to coastline, distance to airport, distance to nearest tourist attraction, highway, park. These types of things, yes, they may be only small 2, 3, 4, 5, 6% or whatever, but if you add all of them up, it becomes actually quite large drivers to what's going on there. And this is how we go about explaining to our sort of customers, saying, look, these are the drivers. And I think once you start to see some of this type of information, these are the drivers, I think that dauntingness of like, oh, I don't know what AI is, I don't know what machine learning is, it starts to peter away. Because if you're able to say, look, this is £200,000, and the valuer says, yeah, I think it's about £200,000 in this area as well, and you're able to say, well, look, these are the drivers, oh yeah, that's what I would do in my job. I would say, well, look, how far away, it becomes a bit easier for you to sort of grasp. So I think that's how we think about explainability, getting the customer comfortable with what we've done and explaining what those drivers are. And I think if you can marry that up, then actually it makes the RICS members' life a bit easier.
Well, it does, and let's say I think at every level through that chain of client through valuer, that there needs to be that transparency of what those drivers are. And I suppose it also leads to that sometimes a bit of a critique around AVMs about their ability to forward look, is that you also then need to understand, well, actually as the market reacts to changes in what people think is important, that should be seen in the model. And I suppose that's one of the challenges, I suppose, is one is always looking at a degree of historical pricing in terms of transfer, but obviously that if you can get up-to-date data in terms of rental values and obviously capital values very quickly, the model should pick up that, to use the cliche in the UK post-COVID, that people want outside space, they want spare bedrooms, and those are becoming increasingly large drivers, or indeed from a locations perspective, that they're more comfortable being outside of the cities now, so that those drivers would, in that kind of model, would become quite apparent quite quickly, I guess.
Yeah, no, I think the good thing with data is, as long as it's relatively live, your models can be quickly updated to sort of consume all of that data. And I think it touches upon a sort of thematic of how different countries in across Europe, how they sort of how you think about consuming data and how the AVM approach works. Let's say here in the UK versus other parts of the other parts of Europe as well. So I think if you think about somewhere like the UK, and look, I think the UK, Holland, a couple of other jurisdictions in Northern Europe, they tend to have quite a large amount of data availability, relatively live information as well. So the adoption of AVMs is no surprise, is relatively at the forefront here in the UK versus some of the other European jurisdictions. So you've got a very mature market. Now you've obviously got portals like Zoopla and Rightmove who've been at this for about 15 or 20 odd years now. I forget, it's quite, you think about how long they've been doing it. They've been doing it for a very long period of time. And the adoption of those types of models and systems as well means that lenders have got comfortable over a period of time. They've sort of gone and tested them. They said, okay, well, these things work really well. They've gone and had physical evaluations conducted alongside those in the early days to make sure that the trust in that system and those AVMs is actually working quite well. Which means that, of course, in places with large data availability, the error rates tend to be quite small. Even if you're using a comparable model as opposed to a machine learning model, the error rates tend to be quite small and acceptable for the end customer to say, well, look, these are pretty accurate. Now, of course, I think we talked about places like Greece and other territories where the land registry equivalent information is just simply not reliable. The data availability is also nowhere near as prevalent. Across Europe, I think there's only 10 open EPC countries as an open data source. Why the others are sort of behind the curtain, I don't know. But of course, the lower the level of data transparency, the lower the level and the confidence that you can get in those models there. That's not to say you can't do anything there. It just means that the end customer has to be accepting that the error rates are going to be a bit wider than would otherwise be the case. The other thing about this as well is, you talked about looking at sort of new data. So let's say in the UK, people want open big gardens and this, that, the other. Now, you can only do that when you sort of track those types of parameters. So are they easy to track? And if they're not there, then what have you got to be guided by? The last aspect on this as well is actually it's quite interesting in that even though the data quality in country A may be very high, but the data quality in country B is very low, that doesn't mean that country B has to go through the same progression channel as country A. So here in the UK, comparable models have been in existence for, as I said, 15, 20 years, however longer Rightmove and Zoopla have been in existence. Now, when we went to Greece, we said, well, look, why do we need a comparable? We built one anyway, just to sort of test our models. But we went straight to a machine learning model. We said, look, the error rates will be smaller. It's going to be more accurate. It is explainable. You don't have to be daunted about that, as I've mentioned here. So we didn't need to start with a comparable model, and it's that same sort of old concept that I'm sure everybody's heard before, where you didn't really need the lots and lots of landlines in Africa. They just went straight to mobile. Exactly. So you don't have to start with the natural building blocks that you think another country's done. You can leap straight through as well, which is quite interesting.
No, that's great. This has been an intriguing conversation. I guess I'd like to almost sort of this first episode that you and I chat, and I'd like to kind of end it with a bit of a sort of $64 million question about what the future of AVMs is in your opinion. And also, you mentioned earlier about some initial sort of dipping the toe into the water of commercial real estate, and obviously that's a very different asset class in terms of the heterogeneous nature, the issue of leases and covenant strength and filling voids, and it is a very different sort of characteristic in terms of the data sets, and indeed arguably big data, given that there are a smaller number of assets, and obviously perhaps one could argue the lack of transparency to a large degree in the kind of opaqueness of that private market. But I'm intrigued to hear what you think of what the future of AVMs looks like, and whether you feel that perhaps for more homogeneous commercial real estate, that indeed these techniques will have a role.
Yeah, no, look, I think I've hopefully put up a slide and I sort of given you a bit of the evolution of the pre and the future as well. So I think you know, in sort of valuation 1.0, this was where I was at my old job. This was what I was suffering. Very manual process. It wasn't easy. It was not, you know, it was not what I was expecting. And you know, I think in 2020 and also 2025, and we've certainly been sort of covering both of these. There has been adoption of sort of process automation amongst a few people, not everybody. But then I think in sort of 2025, and this is kind of where we already are, is we're sort of consuming non-traditional data sets, things like images, this, that, the other. We talked about machine learning and regression models, etc. So, you know, there's certainly a few companies that are at the fore in terms of building out what's going to come to the future, but the adoption is clearly not there. It's the only, you know, the 1% or something like this. Now, I think I had a slide previously in terms of which asset classes are relatively easier than others within the sort of real estate spectrum, and it's not surprising that obviously something like residential is easier to sort of automate and build out machine learning AVM models because there's a vast amount of data available there. Now, the pilot that sort of trying to answer that question, the pilot that we did was on granular commercial. So we're talking about, you know, 100,000 euros, 200,000 euros, 300,000 euro retail shops or whatever it might be, or offices, you know, quite small in nature. These are not large, you know, 100 million euro office blocks, just to be very clear. Now, we went through that pilot, and there was certainly a lot of learnings that we got from there. One is that it's nowhere near, of course, as easy as residential. I don't think that's a surprise, but you know, some of the things that we were looking at. I'll give you an example of what we saw in one of those, or several of those properties actually, but all in the same sort of location. You had location A, which was a retail area, and then you had location B, which was also a retail area, but maybe 600, 700 meters away, if you were to just look at it on Google Maps. Now, in that instance there, you're like, oh, they're relatively close, so actually this should be fine, and you can take some inference of some of that there. What, of course, and this is where the sort of the real estate experts come to the fore, is, well, in the middle of there's a mountain, so actually the travel time that it takes was something like 20, 30 minutes or so, or something like that. So actually two completely different retail experiences. And you know, these things were off by quite a margin, as you can probably already gather. So, you know, we saw that, we said, okay, well, look, now we need to think about travel time, destinations, etc., and trying to figure out what that is. It's quite interesting because we had another conversation probably about a month and a half ago, where we had a conversation with somebody who was looking at sort of the sort of warehouse distribution. So think about like your Ubers or your Waitrose or Cardos or these types of things here. Now, again, it's a travel time conversation. It's not a distance conversation. It's like, well, look, if I'm in the centre of London, sure, if you can afford it, go into Knightsbridge, and so you'll have a huge catchment area. But the problem is, do you genuinely do? Because you know, what's traffic like? How easy is it to get to that customer? You know, am I going at peak hours? Am I going at something like that? So what a distribution center in that instance is trying to do is trying to say, well, look, what is my catchment area given a sort of time constraint and given my peak hours of operation? Where should I be positioning? Should I be here, or should I be there, or whatever it is? And then obviously there's a cost benefit analysis, because you know, as I said, you know, Knightsbridge is always really nice to have something, but probably slightly pricey as well. So I think you know, in terms of sort of the commercial real estate asset class, there's a lot of interesting themes. We spoke to another customer who was looking at the hospitality industry and saying, can you take hospitality into, let's say, you know, student accommodation or assisted living or whatever it might be, and what are the sort of low level solutions that can be applied that doesn't increase too much in the capex spend, but will give an extra premium service. So it's very, you know, you can see these are all kind of quite unique conversations. If they're unique in nature, they're not you know, large like residential. It becomes quite tricky. Then you also talked about you know, looking at the contracts. Now there are technologies known as sort of natural language processing and things like this, which take out keywords, you know, take out term or length of the lease, or you know, all of these types of things. But within a sort of broader prop tech space, I know that there's like 2 or 3 companies that have just started looking at that. So you're building up little layers from different companies doing little things. So I don't think it's insurmountable. I just don't think one company is going to deliver it. What I suspect is going to happen is you're going to have like 5 or 6 companies who've done very good things within whatever their verticals are, probably get gobbled up by a JLL or a CBRE or one of these types of outfits, and then have a holistic solution across there because they've got the sort of technology built out there. So I think it's going to be a challenging thing. I don't think the adoption of that is going to be now. I think it's a good sanity check probably right now in commercial real estate is my view. You can automate this. You can save a lot of time and effort is probably what you can save. In terms of the actual output of evaluation, I think there's still a bit more to go.
Oh yeah, I'd agree. I think what's interesting is that as these kinds of approaches that have been used in sectors like residential are applied appropriately to the kind of data econometrics and footfall, and as you say, distance metrics in terms of connectivity, essential people, people are still putting value on commercial property, whether it's looking at the rent roll or whether they're looking at an empty building and deciding its attractiveness as you say, either as retail or mixed use. So I think it's inevitable these techniques will begin to positively spill into that sector. But as ever, I think it just needs the professionals to kind of oversee the implementation and make sure that as ever, it's not garbage in, garbage out. Well, that's been a fascinating conversation, Manish, and I look forward to our next conversation about the application of the kind of technology and analytics you're using in lots of different cases of real estate. So it's been great to talk, and I look forward to talking again.
Yeah, look, really appreciate the time, Andrew. And yeah, look, I think we're really here to help. We've started working with some of your firms, so we'd love to work with more. And yeah, look, happy to give out a bit more thought pieces for sure if you'll find that useful. So yeah, appreciate your time and thanks for having me.
Yeah, pleasure.